Somewhere in Magento right now, code calls a method named save, hands it a product, and gets a product back. That calling code has never heard of a database table, never heard of a class called product repository, and never will. It only knows an interface. Today we open the real source behind that separation product repository interface, the product interface data contract it depends on, the concrete product repository class that actually does the work, and the single line of XML that connects them, and trace why Magento was built so that the thing you depend on and the thing that actually runs are never the same file. Welcome back to Magento Development Deep Dive. We've covered dependency injection, plugins, and events, 3 ways Magento lets code hook into other code. Part 6 covers something different, the contracts Magento itself is built out of. We're reading the real product repository interface, the real product interface data contract, the real product repository class, and the real di configuration line that wires them together, all from the same pin tag we've used all series, 2.4.9, so every file and line you see is something you can open yourself. By the end of this part, 5 things should click. What a service contract actually is, stripped of buzzwords and interface describing behavior, plus a data interface describing shape, and nothing else. Why product repository interface, the contract every product saving call goes through, never once mentions a database connection, a collection, or a line of SQL. How product interface separates what a product has: a SKU, a price, a name, from how a product is actually stored, which is the concrete product class's problem, not the interface's. Why the real product repository class gets bound to that interface through a single preference line in di configuration, not a hard reference anywhere in calling code. And how this exact same pattern is what lets Magento expose REST and GraphQL APIs for products without writing a single extra line of business logic. Strip away the code, and a service contract is 5 stages. Contract: product repository interface declares behavior save, getById, delete, getList with 0 implementation. Data shape: product interface declares what a product is: SKU, name, price, and the rest again with 0 implementation, just getters and setters. Bind: one line in di configuration tells the object manager that whenever code asks for product repository interface, it should actually receive an instance of the concrete product repository class. Implement: that concrete class does the real work, loading, caching, validating, saving through a resource model. And consume: every single piece of code anywhere in Magento that needs to save or fetch a product asks for the interface, never the concrete class, which is the entire point. A few things help before we dig in. Part 3, on dependency injection, is essentially a prerequisite here. The preference element we'll see today is the exact same mechanism from that episode, just applied to a service contract instead of a generic class swap. Either a real Magento 2.4.9 checkout, or the GitHub tag open in a browser tab. Comfort reading a plain PHP interface and basic XML is enough. No prior experience with the repository pattern in any other framework or language is needed. We're building the vocabulary entirely from Magento's own real source. This is the real product repository interface, trimmed to its method signatures. Notice what's missing: no database class, no collection, no SQL, not even a hint of how a product actually gets stored. Save takes a product interface and returns 1. Get takes a plain string SKU. GetById takes a plain integer ID. Every parameter and return type is either a scalar or another interface product interface itself. Whatever eventually implements this contract could store products in a relational database, a document store, or a flat file, and not one line of calling code would need to change. This is the real product interface data contract. Notice the shape is identical in spirit to product repository interface pure declaration, no bodies. The constants at the top, SKU, name, price, are just string keys, used so that code reading or writing product data by array key never has to hardcode a typo-prone string literal. Get SKU and set SKU are the entire public surface for that one piece of data. Nothing here says whether SKU is a database column, a cached value, or computed on the fly. That decision belongs entirely to whatever class implements this interface. This is the real catalog module di configuration, and these are 2 of its very first lines. Preference for product interface, type product, meaning the concrete product model class is what actually answers get SKU and set SKU. Preference for product repository interface, type product repository, meaning that concrete class is what actually answers save and getById. This is the entire binding. If you wanted to replace how products are stored, you would write your own class implementing these same interfaces, and override just these 2 lines in your own module's di configuration. Nothing else in Magento would need to know. This is the real class declaration, and it's the other half of the binding we just saw in di configuration. The implements keyword right here is what makes this class legal to satisfy that preference at all. Product repository takes 24 collaborators through its constructor, a product factory, a resource model, a search results factory, and many more, none of which are visible from the interface. That's the whole point of a service contract. All of this complexity is real, but it's entirely invisible to anything that only knows product repository interface. This is the real get method body. Underneath the interface's simple one-line signature is a resource model lookup, a local in-memory cache check we're skipping over here, and a load call that hits the actual database. Notice the no such entity exception. That exact exception class is named right there in Product Repository Interface's own .comment as something callers should expect. The contract doesn't just declare a method signature, it declares which failures are possible, so calling code can catch them without knowing anything about how the lookup actually happens underneath. getById looks almost identical to get, and that's a deliberate design choice worth noticing, not a flaw. Magento products are addressable by two completely different keys, an internal numeric ID and a merchant-facing SKU, and the interface exposes both as separate first-class methods rather than forcing one lookup path to guess which kind of value it received. Both throw the same no such entity exception type, so calling code can handle either lookup failure identically, even though the two methods query differently underneath. This is the real getList signature, and it's the clearest sign that these contracts were designed for more than one caller. Search criteria interface is a generic, framework-wide filtering and sorting contract, not anything specific to products or databases. The same interface powers search on categories, orders, and customers. GetList returns product search results interface, which itself just exposes get items and get total count. This exact same signature is what the REST and GraphQL layers call directly. There's no separate query building code for the web API, because the contract was already generic enough to serve it. One quick way to confirm this binding yourself in a real checkout: grep the di configuration for the interface name, and grep the model class for the word implements. Two completely separate files, in two completely separate directories, one declaring a contract and one binding to it, agree with each other only because a string in XML happens to match a namespace in PHP. There's no compiler cross-checking these two files against each other at write time. If the class name and di configuration were ever misspelled, Magento would only fail at runtime, when the object manager tries to build something that doesn't exist. A few things trip people up here. Interfaces marked with an @API tag in their .comment are meant to be treated as stable, public API surface, even for code living inside your own custom module. Changing their method signatures is a breaking change for anyone who implemented or called them. Data interfaces like ProductInterface only expose getters and setters. Any validation, computed defaults, or business rules belong in the repository or the model, never squeezed into the data interface itself. Overriding a preference swaps out the entire concrete class, not just one method. If you only need to change one piece of behavior, a plugin on top of the existing class is almost always the better tool, which ties directly back to part 4. And getList silently returns unfiltered or unsorted results if the collection processor referenced in di configuration isn't wired correctly. There's no exception, just results that quietly don't match your search criteria. Let's pull service contracts back together. Product repository interface declares pure behavior, product interface declares pure data shape, and neither one contains a single line of real implementation. A preference element in di configuration is the entire binding between an interface and its concrete class. One line, in one file, is the only place that decision lives. Product repository's own class declaration is the other half of that agreement, since implementing the interface is what makes the binding legal in the first place. Get and getById throw the same documented exception type from two genuinely different lookup paths, SKU versus numeric ID. And getList's use of a generic search criteria contract is exactly why Magento's REST and GraphQL layers can reuse the same repository directly, instead of needing separate query logic for the web API. That's how Magento's service contracts actually separate what code depends on from what code runs, straight from the pin 2.4.9 source with every file and line cited. Part 7 goes underneath product interface itself, into EAV attributes, entity types, and the EV_attribute table that makes a product's shape configurable in the first place. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 7.